This video will give you a quick overview of how to get up and running with the ASN Filter Designer. I'll walk you through the user interface, the help menus and coaching tips, then show you how to design a simple IIR filter and validate it in the real-time signal analyzer. We will also explore the symbolic scripting IDE, and then finish off by looking at deployment options, where licensed users can generate code for Arm Cortex-M devices such as the STM32, as well as for Python and MATLAB projects. After downloading and installing the ASN Filter Designer, the tool decides which mode to run in based on the license file it finds. With a valid license file, it will open in either professional or educational mode. Without a license file, it runs in evaluation mode and shows the help menus and coaching tips on startup. The first thing you'll see is the introduction menu in the center of the screen. This includes links to licensing details and tutorials, and if you decide to upgrade, clicking on the Buy a License button will take you straight to the website and fill in the form with your user ID. Once you close the introduction menu, a coaching tips menu appears that walks you through the basics of interacting with the chart, such as zooming and panning. Finally, you'll see the Getting Started menu, which contains a rich collection of reference designs created by our DSP experts. All of these resources are worth exploring, as they can really help kickstart your development. Once you've navigated through these menus, you'll arrive at the main user interface. Here you'll find the filter frequency response chart, the pole 0Z plane chart, and an options submenu. At startup, the tool automatically designs a low-pass elliptic IIR filter and displays its magnitude and phase frequency response. The specifications used for the design are summarized in the IIR specification table on the right. Although you may edit these values and redesign the filter manually, where the tool excels over other filter design tools is the ability to graphically specify your specifications via the red design markers. Moving the mouse over a design marker and clicking on it allows you to graphically modify the filter's magnitude specification. Notice that the filter is redesigned in real time, allowing you to quickly optimize the filter to meet your design specification. Experiment with other design prototypes such as Butterworth, Chebyshev and Elliptic using the methods menu and quickly converge on the best solution. For beginners, the coaching tips provide hints and tips on which filter method is best suited to which application. Returning to the main filter frequency response chart, notice that there are multiple axes, where the left-hand axis is the filter's magnitude response axis, and the right-hand side y-axis is the filter's phase response axis, and the x-axis is the frequency axis. You may use the mouse wheel to zoom in and out of the chart, and while depressing the left mouse button pan the chart. Using the right mouse button, notice that there are several options to lock an axis, allowing for a very simple way of focusing on a region of interest. For developers working on biomedical and predictive maintenance applications, the tool implements a baseline wander tracker that allows you to design a very low cutoff linear phase high-pass filter, needed for IEC compliance. Also notice that the baseline wander tracker supports the design of low-pass filters, which is ideal for DC measurement applications from bridge sensors, such as load cells. As with the main filter designer, the cutoff frequency can be fine-tuned with the mouse, like so. After designing the filter, you can validate the design with the tool's built-in signal analyzer. Opening the signal generator UI, we can design a test signal by checking the required entries in the list box and setting the properties. To begin the simulation, we just click on the play button and the tool starts streaming data into our filter, where the filtered result is shown as the red line. Notice that the filter coefficients are updated in real time, and any changes to the filter's design specification would be automatically updated in the signal analyzer. As default, the time domain analysis is selected, but you may also switch to frequency domain analysis via the chart options menu. As seen, the signal analyzer provides a rich collection of support functions, including a powerful CSV data file import wizard, as well as various time domain analytics functions and data shifting options. All of these features allow you to quickly perform detailed data analysis with your test datasets and validate filter performance before deployment. Also notice that the analyzer provides a zero-phase filtering option, which is ideal for evaluation of biomedical datasets using nonlinear phase IIR filters. When you're satisfied with your design, licensed users can deploy their designs to various frameworks such as C, C#, Python and MATLAB, using the automatic code generators. This easy method of deployment allows you to stay with your preferred tools without making any compromises. Detailed tutorials are available on the website on how to use these frameworks for your projects. For professional license users, the Arm Deployment Wizard is a simple one-click option for generating C code using Arm's CM/SysDSP framework. The tool will automatically analyze the complete filter cascade, and if it can't be deployed using CM/SysDSP, will choose ASN's highly optimized CDSP framework. The built-in deployment wizard bundles the filter cascade design parameters and all of the necessary framework files for use in industry-standard IDEs, such as IAR, eWarm, KileMDK, and STM32 IDE Cube. You may, of course, get a summary of the complete design by clicking on the Filter Summary button. As seen, in documentation mode, a complete summary of the filter cascade is given, which is suitable for formal documentation, as the summary can be copied and pasted directly into Microsoft Word. For FPGA designers, you can also get an implementation cost report like so. And as an added bonus, the tool includes a Vivado code generator for FIR filters for direct use in your FPGA projects. Beyond code deployment, one of the most powerful features of the tool is its real-time scripting language, referred to as ASN FilterScript. With over 80 scientific functions built in, FilterScript lets you design and customize specialist filters with advanced specifications, all through easy-to-understand symbolic mathematical expressions. A built-in IntelliSense helps with the syntax. This is strengthened with loads of examples provided in the examples directory, as well as reference designs via the Getting Started menu and detailed online help, including a comprehensive reference guide. We also offer an Ask a DSP expert service, allowing you to get expert advice from our DSP team whenever you need guidance. That's how simple it is to go from filter design through to validation and deployment with the ASN Filter Designer, and I hope this short overview has inspired you for how the tool can accelerate your projects. For more tutorials and resources, visit our website, and if you have any questions, we'll be happy to help.